Hello guys, welcome to another video, and in this video we are going to configure two types of VPNs, and they are both are hub to spoke and spoke to spoke. One is going to be DMVPN, which is using IKE version 1 over here, and of course we're also going to be using NHRP because without NHRP we are not able to form spoke to spoke communication. And that's going to be the DMVPN. And then we have FlexVPN, which is with IKE version 2. They also call it FlexVPN Spoke to Spoke, or they call it FlexVPN DVTI. It depends who you're talking to. So this FlexVPN Spoke to Spoke is going to have a hub to spoke communication, also spoke to spoke communication using IKE v2, which is a lot better than IKE version 1. As you know, Cisco does not recommend um, to configure IKE version 1 at all. I believe they have that disabled on the routers and firewalls as well. So we're going to have both configuration done, and we are going to start with the DMVPN configuration. And this one is going to be DMVPN Phase version 3, which is the one that have spoke-to-spoke communication, and it has NHRP shortcut, NHRP redirect, and all that good stuff. So let's go and start with that. So here we are. Let's see if we can move this over here so we can see our topology, at least half of it. There we go. And we are going to start with the hub, like we always do. Okay. So the first thing that we want to do is configure IKE version 1 first one. We want to do a crypto ISACAMP policy. And in here in this policy, you want to do that. You want to specify what encryption method you want to be using. 3-dash, what hashing algorithm. We're going to use an MD5. Different Hammond group number, we're going to use 2. And the encryption method, or not encryption, how are we going to authenticate? Using a picture key. And the picture key is going to be defined on the other IKE version 1 phase 1, doing a crypto ISACAM key, not not keep alive, um, crypto ISACAM key, CCMP, CCMP sec, and then you want to give it the address. And with this wildcard, I'm saying that I want anybody, right, any IP address that has this key. So I'm going to be able to authenticate to any router, but whoever has this key though, but to any IP address. If you want to specify an IP address, you can do it. So right here. But I'm just going to leave it like that since I'm going to authenticate with two different routers, and it's a little bit easier to manipulate. Then after that, we are done with IKE version 1 phase 1. Now we're going to configure IKE version 2, IKE version 1 phase 2. I'm sorry. So IKE version 1 phase 2. Let's go ahead and do that. And that intakes IPsec. So crypto IPsec transform set. We're just going to call it tset ESP AES256 with ESP SHA and also HMAC included. Exit. Then we do a crypto IPsec profile. IPsec profile. And inside right here, all we need to do is attach the transform set, which we call tset, over here. Okay. So IKE version 1 is going to create the tunnel. It's going to create a secure tunnel so we can then transform, so we can then send traffic using IPsec. Okay, so IKE version 1 secures IKE version 1 phase 1 secures IKE version 1 phase 2, basically. Okay, so we are done with that. Now, after that is done, let's do an IP. Let's see, we're going to do interface. I'm going to do an interface. Actually, we have to do for, yeah, for phase 1 is the tunnel. So tunnel, just say tunnel 0. IP address is going to be 192.1. 168.10.1. And router 4 is going to have that 4, and router 5 over here is going to have that 5 for the tunnel. Okay, so that is good. Then we're going to do a no IP redirect. Then we're going to do no IP next hop self EIGRP 100 or EIGRP 10. And this is so that the hub doesn't list itself has the next hops for the routing updates of the spokes. Then we're going to do no IP split horizon, EIGRP autonomous system 10. Then we do an IP NHRP map multicast, going to be dynamic. IP NHRP network ID, let's just say 10. Tunnel source gigabit 0, that's the source of the hub, gigabit 00. So that's good. Then we want to specify the IP NHRP shortcut command. Shortcut is also going to be configured on the spokes, which is responsible to rewrite the CEF entry after getting the redirect message. So we need to do IP NHRP redirect message. So what that's going to do is whenever router 4 communicates with router 5 over here, and what's going to happen, the first packet is going to be sent to the hub, and then the hub is going to be, hey, there's a better way or a faster way or a more direct way to get to router 5, and it's going to send it because it's going to be triggered by a redirect message, and it's going to send it to router 4. And then router 4 is going to catch it with the IP shortcut, and it's going to add it to its routing table, and it's going to create a spoke-to-spoke communication with router 4. You guys are going to see that whenever we configure everything. I'm going to show you whenever it's done. Then we want to do a tunnel mode, and it's going to be a GRE, a multi-point 1. So tunnel mode GRE multi-point, and then you want to do a tunnel protection using IPsec profile that we created, and we name it IPsec profile. ISACAM should come up. Now we want to do a router EIGRP 10, and we want to let them see do show IP interface brief. So we want to add my loopback address and also this tunnel IP address. Let's first do no auto summary, then network 9.9.9. Actually, it's a wildcard. And then network 192.168.10.0 to 5. Exit. Let's just go ahead and end it. And then let's do a show run. Let's do a section of crypto. And over here, we are going to copy we're going to copy Version 1 Phase 1 and Version 1 Phase 2, and we're going to put it on a notepad, right? Because it's going to be the same configuration. So all we have to do is just copy and paste it into the other two routers. Good, good. And then let's also copy show section EIGRP. We can copy this, paste it right here. Let's go to router 4. And router 4 is going to have a different tunnel configuration. So in the tunnel, let's go ahead and just create it right now. Interface tunnel 0, the IP address of it for router 4 is going to be 192.168.1 or that 10.4. And then it's going to have a IP NHRP NHS. NHS means the next hop server. We need to identify the next hop server, which is 192.168.10.1, the IP address of the tunnel interface of the hub. And then we're going to say the NBMA IP address, so that's going to be 192.1.90.1.1.90.1. Then we do a IP NHRP map multicast. This means that all the multicast traffic, I wanted to send it to 192.1.90.1, which is the NVMe IP address of the hub. And multicast traffic is the traffic of the dynamic routing, which is for EIGRP or SPF or any of that. Since we're using EIGRP, we need to put multicast because we're using a dynamic routing interface or dynamic routing. Then you want to do a tunnel source. Let me see what's the source of it. Router 4 is gigabit 01. And then we want to do a IP NHRP network ID, and we set it 10. It needs to match the same as the hub. Then we do IP, or not IP, yeah, IP NHRP shortcut. Um, I forgot a P right here. So IP NHRP shortcut, and then you want to do a tunnel mode GRE multi-point. And after that's done, you want to do a tunnel protection IPsec profile IPsec profile, which is going to be configured right here. Let's go ahead and remove this from over here, and it's going to be pasted down here. And for this one, let's do a do show IP interface brief. We want to have loopback 0. So this one is going to be 4.4.4.4, and the rest is going to be the same. Okay, so let's go ahead and everything has been configured. It looks like it's good. Go ahead and copy all of this and paste it into router 4. Okay, you can see ISACamp came up. EIGRP has a new neighbor, which is the hub. So you can see we have a new adjacency, and we also receive those crypto. So the IPsec tunnel is up. If we do a show IP EIGRP neighbors, we have a new neighbor 192.168.10.4, which is router 4. We do a show crypto ISACamp SA. We should have an ISACamp SA up and running. Show IP interface brief. The tunnel is up, so that's good. If we want to see a show crypto, it's a crypto engine connections active. You can see the active connections that we have right now. So that's good. Everything is working. So show, if you do a show IP DMVPN, or show DMVPN, you can see we have a DMVPN configure. Also show IP NHRP. You can see that we have a NHRP created, which was dynamically learned. The tunnel IP address 192.168.10.4, the IP address of router 4, and then the NVMe IP address of router 4 as well. IP address router 4 should also have the same. There we go. But this one was statically configured because we manually enter it when we set that IP and SRP and HS. This right here says that it was statically configured. And since we did not do it for the DMVPN, it was learned dynamically. You can see we here type dynamically. Now let's go ahead and configure router 5. And all we have to do right here is change this to 5.5.5.5, which is a loopback IP address. The source interface is gigabit 02. The IP address is going to be 5, and then the rest is history. So the rest is the same. Verify 5. Yep, so the rest is going to be the same. So we can just go ahead and copy this and paste it into router 5. Let's go into config mode first. There we go, ISACamp is on, ERGP is up. So now we can see we have a new neighbor relationship and we have a new IPsec tunnel created. we do a show crypto ISA campus A, you see now that we have two, 50.1, 40.1, working good. We can also do the show IP and NHRP, both dynamically learn, the 50 and the 40.5 and the 4. Show DMVPN, we have two connections. We have all those connections. DMVPN, so all is good. So now what's going to happen? Let's go into router 4. Let's do a show IP um, route. And you can see that we have a route to the 5 network. And it's saying that it is via, or we have, let me see, we have this router 4, right? So we're saying that to reach router 5, you have to go via 192.168.10.5. And let's go ahead and do a show IP and HRP. We only have learn one, so we only have one tunnel created. So if we do show crypto ISA campus A, you're going to see that we only have one tunnel created. I hope to spoke communication and only one NHRP tunnel right here. So now if we do a trace route to 5.5.5.5, you're going to see that the first packet went through the hub, but then the hub, since it has configured with the IP and SRP redirect, it sent a um, packet or to router 4 telling it that there's the best way to get to router 5, and it is via, if you go ahead and do IP and SRP, you can see now that we have more NHRP um, in here. And what the hub did was that it sent it because it has the um, IP and SRP redirect in here, and this one has a shortcut. So it sent it right here. It sent the shortcut to router 4, and router 4 saved it in their um, database. And what it did was that it sent information about how to reach router 5 directly. So now you can see over here that we learn a new way, and it was dynamically learn. So now if we do a trace route to router 5, it goes now straight to router 5 because now it formed a spoke-to-spoke communication with router 5. So that's how DMVPN works with IKE version 1. So now we are going to configure FlexVPN with DVTI, FlexVPN VN IKE version 2. So let's go ahead and configure that. We can go ahead and close all of this. Let's go ahead and go to the hub, router 1, router 2, and router 3. And let's go ahead and configure all that good stuff. Enable. So from the hub, let's do a show IP interface brief. Okay, config T. So the first steps that we need to do is we need to go ahead and enable a new matter for AAA because we're going to use AAA authorization. We're going to say AAA authorization. We're going to use the network, and it's going to be called FlexVPN list, and we're going to use the local router to authenticate because we're not going to be using, you could either use a group, and a group will give you the radius, TACAX, or LDAP. So since we're not using that, we're going to use the local. You can just go ahead and choose local. Then you want to go ahead and do a permit access list. It's going to be standard, and we're going to be call this flex ACL. And here we're going to what we want to permit. We want to permit any because we need to permit traffic coming from router 3, router 2, and router 1. So let's just go ahead and do permit any. So we can allow any traffic. Then after that is done, you want to do a crypto like version 2 authorization policy. We're going to use the default policy. And inside this default policy, we want to set, or we want to route set interface. Then we want to do a route set access list, and we want to add the access list that we just created, which says to just permit any. All right. After that is done, we want to do a crypto IKv2 keyring. We're going to call it IKv2 keyring. And inside right here, we want to do the peer. It's going to be any peer. The address, we are going to do a wildcard mask to any IP address. And the pre-shared key is going to be, we are going to call your CCNP security. And that's going to be the key that is going to be used by router 3, router 2, and router 1 to access or to authenticate um, with that iversion 2 phase 1. Okay. After that is done, we need to go ahead and create a crypto IKv2 profile. We're going to call this IKv2 profile. And inside right here, we need to do a match identity of the remote address, wildcard mask again. Then you want to do a match identity remote to an IP address. Then you want to do authenticate remote. It's going to be pre-shared key because you're using the keyring, and the keyring has a pre-shared key configured to it. And then local, also using a pre-shared key. Then you want to attach the IKv2 local keyring, which we call IKv2 keyring, I believe. Where is it? Where is the IKv2 keyring? Right here, IKv2 keyring. IKv2 keyring, good. Then after that is done, we're going to attach the virtual template, which is going to be virtual template 8 that we have not created yet, but we're going to create it next. Then we need to add the authorization that we created, and it was a group using the pre-share key, the list. We call the list, if I can find it. There we go, FlexVPN list. Paste it right here, and then the authorization, the IKv2 authorization that we used was the default. Let's see if I can find that in here. There we go. The IKv2 authorization policy was the default, so we need to add the default at the end. Done. So we are done with IKv2 profile, the IKv2 keyring, IKv2 authorization policy. Now we need to do the crypto IPsec transform set and the crypto IPsec profile. So crypto IPsec transform set, we are going to call this T set. We're going to use ESP AES256 and ESP SHA with HMAC. Exit, we do the crypto IPsec profile. We're going to name this IPsec profile. We're going to set the transform set, and we name the transform set T set. And then we're going to set the IKv2 profile, which we call IKv2 profile. Okay. Then let's go ahead and configure the template interface virtual template name, which is 8 type tonal, which was the same one that we attached to the IKv2 profile. Okay, there we go. And then after that is done, we want to do the tonal source gigabit 00, gigabit 0. And then the IP address is going to be a number. And I believe if we do show IP interface brief, we want to use loopback 8. So IP a number, loopback 8. After that is done, let's do an IP NHRP, redirect, and IP NHRP network ID 1, tunnel protection, IPsec profile. We name the IPsec profile IPsec profile. Good. So since most of the configuration It's going to be the same. We are also going to be using LivePad for that. So we can just copy and paste my configuration in here. So let's go ahead and end it. Do a show. Ah, let's go ahead and cancel that show. Run section crypto. We want to go ahead and copy all of this because it's going to be identical to what we have done. Also, you want to, let's go all the way over here. We want to get the first AAA, we have to say AAA new model, and then AAA authorization. So AAA new model, then AAA authorization, flex list, and it was a local one. Copy, paste it right here. Then we create a IP access list, FlexVPN, and we want to permit the IP address of the loopback of router 1. So if we get that information, enable show IP interface brief, which is 1.1.1.1. So we want to permit 1.1.1.1. There we go. And after that, we configure um, the crypto IP2 authorization policy. Copy it, paste it in here. And inside this policy, we just set the route set to interface, and then we added the access list, FlexVPN ACL. And then after that, we did the IPv2 keyring, which is not in here. Let's go ahead and do show crypto IPv2 keyring. No, doesn't show it. Okay, let's do a show run section keyring. And here's the keyring. We want to go ahead and copy all of this, paste it in here. And in the keyring, we need to just say that the peer, and we need to connect to the server or the hub. Let's just go ahead and call it hub. And the hub is this one over here. And we need to specify the IP address of the hub, which is 192, let me see, 192.1.80.1. 1.80.1, CCNP security. And then you want to do another peer, which is going to be for all the spokes. So for router 2 and router 3, we are going to authenticate. Let's just go and do spokes. And this one right here, we're going to just set a wildcard mask. There you go. So that's good. Keyring. Let's see what else we did. And then after the keyring, we did the IPsec profile, match keyring. The template is going to be 1. That's why we're going to name it over here. Default FlexVPN list. So all of that is good. IPsec is going to stay the same. So for now we're here, from router 1, we need to create a tunnel interface. And the tunnel interface is going to connect to the hub, and then we need to create a template which is going to connect with router 2 and router 3 spokes. Okay, so let's go ahead and do that. So I can just go ahead and configure over here the interface tunnel. You're going to say tunnel 0. So go ahead and make some space. You want to do the IP address. We are going to get the IP address of router 1. We are going to use loopback 0 for that. So let's go ahead and bring up IP address or IP or number loopback 0. Then we want to do a tunnel mode GRE over IPv4 tunnel source for router 1 is gigabit 00. Then we do tunnel destination because it's going to be spoke to spoke destination. It's going to be 192.1.80.1, which is the NBMA IP address of the hub. Good. Then we do IP NHRP shortcut, and we want to say that we're going to use virtual template 1, which we're going to configure next. Then the tunnel protection. Tunnel protection is going to use IPsec profile, and we name that IPsec profile IPsec profile. Then we create the interface virtual template, virtual template 1. We specify right here. It's going to be type tunnel, and inside right here we're going to use IP on number, and we're going to use tunnel 0. So let's go ahead and make this tunnel 1. Let's make all the same numbers. Tunnel 1 IP network ID. I believe it was 1 for the hub. Let me verify it. Let's do a shell run. It also needs to be in here. So IP NHRP network 1. That's how it needs to be. It also needs to be in here somewhere. So we did the shortcut to the template. And then we do the tunnel protection, which is the same. So on number IP NHRP network ID, you could also do the IP NHRP shortcut, which needs to be the same. There we go. So we have configured everything. So what's going to happen is that this tunnel is going to create a tunnel with the hub, and then this template is going to create a tunnel with the spokes. Okay, and that's why whenever the hub sends a IP NHRP redirect message to the router 1, router 1 is going to create a spoke-to-spoke communication with router 2 and router 3 using the virtual template. So that's good. Let's go ahead and just copy and paste everything. To router 1 config T, and I want to do it this half first. Make sure I don't get any errors. I did not see any errors. That's good. Now let's go ahead and create IKE version 2 profile and IPsec profile and the T set as well, the transform set. No errors. That's good. Now let's go ahead and copy this interface, which is the one that's going to create a tunnel with the hub. And now we already see I have an error tunnel, and it is with the tunnel mode GRE. So tunnel mode GRE over IP. There we go. It is not IPv4, it is just IP. And then I did not add the tunnel protection at the end. So let's go ahead and add that tunnel protection. Protection. There we go. So let's go ahead and change that protection. And tunnel mode GRE IP. You can see that ISACamp is up. We have a virtual interface, show IP interface brief. We have a virtual access, show IP interface brief, or actually do show. And the interface is down for this tunnel. So let's see what we miss. Show run. Loop back on number, ID, shortcut, source, destination, protection. That looks good to me. So tunnel temporary disable. Okay. So I believe I know why this is it. So what we need to do is, if we do a show IP route, you can see that I have a static route, a default route. So we need to go ahead and delete that. So let's go ahead and do no IP route to this, and it's sending it to 192.1.10.2. And we can do IP route. We can do just one static route to 192.1.80.0, 255.255.255.0. Send it to 192.1.10.2. Interface tunnel 1. Let's go ahead and shut it down and then do no shutdown. Let's change to up. And there we go. So now it is up. So we also need to delete it from router 2 and router 3 and do the same so we don't get that error. No IP route 192.1.20.2. IP route to 192.1.80.0, 255.255.255.0, 192.1.20.2. We need to do it for router 3. Config T. No IP route to. We need to delete my default route. .30.2. Then do IP route to 192.1.80.0. 192.1.30.2. And that should be good for all of them. So now you can see that we have those that DVTI working. So if we do a show IP interface brief, you're going to see that template created a virtual access tool. Here's the IP address. If we do a show crypto IPv2 SA, you can see the SA in here. So it is working. So now router 1 created a tunnel via tunnel 1 with the hub. So now we need to go ahead and create this virtual template that's going to create a spoke-to-spoke communication with router 2 and router 3. So we copy everything and paste it in here. Let's go ahead and protection. There we go. Let's go ahead and remove that from over here. So that's good. So now if we do show IP interface brief, we have now a virtual template. It's not assigned. They did not assign that. You cannot use interface. Okay, so let's go ahead and use the loopback then. So we're going to use loopback 0. So this one is going to be loopback 0, which is basically the same IP address that we're going to borrow. Okay, we do show IP interface brief. You can see right here 1.1.1. Good. So now we need to go ahead and configure router 2 and router 3. Router 2, do show IP interface brief. We want to verify that we're using loopback 0, so that's good. So all we need to change right here, let me see. Let's just go ahead and say we're going to use tunnel 2, network ID 1, template 2, template 2, template 2. Anything else that we got to change? We got to change this one. Needs to say 2.2.2.2. Keyring the same. So everything stays the same. Over here, virtual 2. So everything is going to stay the same for router 2. So let's go ahead and copy this first. No errors. Let's go ahead and do the other half. No errors. Good. Tunnel 2, template 2, destination, source is the same. Go ahead and copy it. Paste. Good. So now you can see as campus up, tunnel interface is up. If we go ahead to the hub, if we do show crypto accuracy 2SA, now we have two SAs over here. If we do show IP interface brief, we have access 1, virtual access 1, and virtual access 2. So that's good. So now let's go ahead and go to router 2 and finish with this one right here. Good. And it's down because we don't have any spoke-to-spoke communication right now. So that is fine. If you go ahead to the hub and do show IP routes, you're going to see a couple routes to the one network, which is router 1, and to the 2 network, which is router 2. We don't see router 3 because we have not configured yet, and we're going to configure now. Let's go ahead and change this to 3, 3, 3, 3. What else? What else? 3, and also the access list to 3.3.3.3. And also let's verify from router 3. Do show IP interface brief. Loopback 0, 3.3.3.3. Good. So now we can just go ahead and copy all of this and paste it because we have verified that everything works with no errors. Copy. Okay. Paste everything. And there we go. With no errors. Let's go ahead and go to the hub. You can see that we have another virtual interface up. Show IP route. You can see the 3 network right here. And if you do a show IP interface brief, you have access 1, 2, and 3 using the same IP address. So if we do a show crypto IP2 SAs, we should have 3 SAs over here, or 3 security associations. There we go. One is for router 1, router 3, and then we have router 2. Okay, so that's good. So now let's see what happens whenever we try to, from router 1, we try to reach router 2. Let's see what's going to happen. And what I believe, or what it should happen, is that if we do show crypto IP2 SAs, you see that we only have one, which is with the hub. So now whenever I ping router 2, we are going to create another SA or another security association with router 2, and that's going to be a spoke-to-spoke communication. If we do a show IP NHRP, we do not have any. So let's go ahead and do a trace route to 2.2.2.2. And I believe it froze. There we go. So we're going to do it. There we go. And there we go. So now, since it sent it to the hub, and the hub sent that redirect message to router 1. It told router 1 how to get directly to router 2. So let's see if I can do a show IP NHRP. Now you can see that we have NHRP traffic. We see a route to router 2 and a router to yourself and another route to router 2. Dynamically learned. Everything was dynamically learned. This one is still incomplete. I think that one fell. So this one is the correct one. So let's go ahead and try to ping. Or do we want to ping or we want to do a trace route again? Let's go ahead and do a trace route again. You see it right here that it formed another SA. So if you do a show crypto IPv2 SA, you see that we have two SAs, one for um, the hub 192.1.80, and the other one, which is a spoke-to-spoke communication directly to router 1. So that's good. You can see now that we did not go to the hub, as you can see right here. First we went to the hub. Now we go straight to router 2, which is via 2.2.2.2. If you do a show IP route, you're going to see that we have a route to 2.2.2.2. And this sign right here means that it is the most direct hop, right? It is the next hop override, okay? So that's what it's saying. It is saying do not send it to the hub, send it directly to router 2. Now let's go ahead and do another trace route, and let's do it to the router 3 so we can form a spoke-to-spoke communication with it. And we don't see any we don't see any route to 3.3.3.3 because we have not formed a spoke-to-spoke communication yet, because the hub right now it is going to send me that information, and there we go. And if we go to router 3, you're also going to see that we received that. So if we do show crypto IPv2 SA, we should see two SAs, one for the hub and the other one for router 1. Router 1 should have now router 2 and router 3. We do show NHRP, you can see it, everything over here, or show crypto IPv2 SA. You see it right here. So we have one tunnel for router 3 and for router 2, which are spoke to spoke, and one for the hub, which is a hub to spoke communication. Okay, but router 2 only have two SAs, or should only have two SAs, one for um, router for the remote route, for the remote router or router 1, and then another one for the hub. So if we do a trace route to 3.3.3.3, or even a ping or anything like that, it should send it to the hub the first time, and then the hub is going to send it to router 3, and then it's going to send that information to router 2 saying that, hey, here's another way that you can reach router 3, and it's going to send it to me. And then if I do another trace route, since now we built that spoke-to-spoke communication, if we do a show crypto IPv2 SAs, now we have three tunnels. One to router 3, to router 1, and the hub. And router 3 should have the same. The hub, router 1, and router 2. So that's how you can build a FlexVPN DVTI or FlexVPN spoke-to-spoke communication or FlexVPN spoke-to-hub and a, a FlexVPN hub to spoke and a spoke-to-spoke communication with IKE version 2 or aka FlexVPN, right? And we also learned how to create a hub to spoke communication and a spoke to spoke communication with DMVPN, and it was all thanks to NHRP. So NHRP is the protocol that lets us create that spoke to spoke communication, so we don't need to go straight to the hub and then to the spoke. Therefore, if the hub goes down, we still have that route in there, so we know how to get to router 2 and router 3. And also that the hub does not need to be as powerful because it doesn't have to route all the packets to router 3 anymore. So router 1 is able to go directly to router 3. So all the traffic does not go to through route to the hub. Okay, so if the hub goes down, we still have that communication. So this is it for this video, guys. I hope you guys enjoyed this video. And if you guys enjoyed this video, go ahead and click the like button. Also, if you have a Twitter account, go ahead and follow me on Twitter at CCNA Daily Tips. Subscribe to my channel. Thank you guys for watching, and I love you guys. Bye bye.